company has two different applications that must share sensitive data that the company stores in S3. A Java application uses the AWS encryption SDK to encrypt an object before the application uploads it to the Amazon S3. Later, a Python application written with the SDK for Python download and decrypts the object by using the S3 encryption client. A decryption object produces results that are unreadable, even though both clients have the correct IAM permission and specify the same ARN for the KMS key, which action will decrypt the object. So here we are talking about permissions are looking correct to us. What could be the possible reason? Let's see the options. Option A, rewrite the decryption client in Java to perform encryption and decryption in the same language. Okay, that's not valid. You can have encryption and decryption in different languages too. Rewrite the Python application to perform decryption by using the encryption SDK instead of the S3 encryption client. We are using S3 encryption client for a Python application. Okay, we should use encryption SDK. Okay, create a common IAM role for use by both clients. Ensure that both clients use the same role. There is nothing related to the permission. Ensure that the two clients use the same IAM credential. So I'm removing C and D. Okay, what is left in front of me? B is left. So B is the correct answer. Okay. A company is designing a public upload platform on S3. Anyone should be able to upload data that is encrypted with the public. Only the company should be able to decrypt the uploaded data. The company needs to use an asymmetric encryption key for the functionality. Which feature can the company use to directly meet the requirement? It is saying that anyone should be able to upload the data that is encrypted with the public. So we need an encryption while we are uploading the data. So we will go for the client-side encryption with the customer-managed encryption keys. Because client-side encryption with SC managed encryption key is not there. SC managed encryption key is supported as a part of a server-side encryption. A developer has a new serverless application that is composed of 3 AWS Lambda functions and an Amazon DynamoDB table. A developer needs to package and deploy all the components together as a single unit. The developer also must run unit tests for the package locally on a desktop. Which automation tool can the developer use to meet these requirements? So here the goal is they have to use a new serverless application and they want to run the unit test for package locally on desktop. If you have heard about SAM, serverless application model, which is a template-driven approach in order to design and run the serverless application in the AWS. And it also provides you the flexibility to locally test your application using Docker. So I will directly choose D as an option. And I'll say confirm. So D is the correct answer. Other options for Elastic Beanstalk deployment. So you can use Elastic Beanstalk to quickly deploy application. You do not need to learn about the infrastructure that runs the application that you deploy and manage because of past behavior of Elastic Beanstalk. However, you can't deploy Lambda function and DynamoDB as a single unit. That was a requirement. Okay. CloudFormation nested stack. So CloudFormation nested stack can deploy Lambda functions. However, the nested stack does not run unit test locally. Code deploy stage. You can't deploy Lambda functions and DynamoDB table as a single unit by code deploy. What's left? Serverless application model template. Okay. You can use it. This is an open source framework for building serverless application. Okay. Number 54, a developer is preparing a deployment package for a Java implementation of an AWS Lambda function. What should the developer include in the deployment stage? You have to select two. As a part of a deployment package, there would be the compiled application code and the application dependencies. Rest all things will be a part of the Lambda environment. So I'm choosing C and E. Okay. And that gives me the correct choices. A developer runs an AWS CLI command on an EC2 instance. However, the command fails with the following message response. This is a response. How can the developer decode the response in the encoded portion of the message? If a developer has to decode the response, the best way is to use the security token service decode authorization message command to decode the content. Okay. Other options will not support this. If you will read it, let's read the other options. Option A, use the support page case command to create a support ticket. Send the encoded authorization failure message content as a part of a support ticket. Not relevant. Use the KMS service decrypt ciphertext block command to decode the content of the response. And the C, use S3 describe default encryption configuration command to decode the content. I'll go with D. And it's correct. You can see why B is not correct. The KMS decrypt command decrypts the ciphertext that was encrypted by the KMS keys, not relevant to the scenario. Okay, because the content are not encrypted. Option C, the describe default encryption configuration command retrieves information about the default encryption configuration for the AWS account. The content in this scenario are not encrypted. The contents are encoded. Okay. An education company is deploying an integration testing strategy for release of a new learning management platform. The platform is fully serverless and consists of two parts. The front end is an Amazon API gateway, a REST API integrated with an AWS Lambda function. The backend includes static assets stored in the S3 bucket and data stored in the DynamoDB table. For the integration test, the company is creating a separate test environment that includes a copy of each architectural component. The company already has created the backend component for the new test environment. A developer needs to create the front-end component for the new test environment. Which combination of steps should the developer take to meet the requirement? Okay. Create a new Lambda function version for the new function version. Create environment variables that point to the new environment S3 bucket and DynamoDB table. Create a new function alias that points to the new function version. Create a new function alias for the new function alias. Create environment variable that point to the new environment S3 bucket and DynamoDB table. Create a new function version that points to the function alias. Okay, option B. Option C is saying create a new stage for the API, configure the stage integration to point to the Lambda function name and the alias for the new environment. Option D is saying create a new stage for the API, create a stage variable with the value of Lambda function ARN for the new environment. And option E is saying create a new stage for the API, create a stage variable with the values of Lambda function name and alias for the new environment. Okay. So first of all, I will group this into two parts, A, B, C, D, and E. Out of A and B, I'll choose this one, create a new Lambda function version. For the new function version, creates the environment variable that points to the new environment S3 bucket and DynamoDB tables. Create a new function alias that points to the new function version. Okay. Out of C, D, and E, I will choose create a new stage for the API, create a stage variable with the values of the Lambda function name and the alias for the new environment. Okay, let's see. It is correct. You can see why B is not correct. B is not correct. A Lambda alias does not give you the ability to modify the function configuration. It's a reference to a Lambda function version. Okay. If you see, like why C is not correct, API stage configuration do not give you the ability to specify a different integration. Okay. Option D, you can use a stage variable instead of Lambda function name version or the alias. API gateway will dynamically translate the function name version and alias to the full ARN. You don't need to specify it explicitly. Okay. 57, a developer is building a web application that processes and tracks votes. A voting device submits the vote to the S3 bucket named doc example bucket. The application needs to record the vote to the DynamoDB table named example. The developer writes a Lambda function to process the object. The developer writes the following policy for the execution role of Lambda function. You can see. I'm allowing action on DynamoDB and S3. Okay. But the question is saying the developer can run a successful test on the Lambda function. However, the developer could not find a record of the invocation in the logs. What should the developer do to record invocation of this function in the logs? So see, we know that Lambda has a basic execution rule which puts the logs to the CloudWatch. But if you are creating a role and creating a policy by yourself, you need to explicitly provide the permissions for CloudWatch logs. Let's see the option. Modify the Lambda function resource configuration in the management console to log Lambda function invocation to CloudWatch logs. We have to talk about roles and permission. Option B, modify the Lambda code to produce event log output, send the event log output to STD out, redirect the STD out to the CloudWatch logs. Again, not true. Modify the Lambda execution rule to have permission to create log group, log stream, and log event in the CloudWatch logs. It is something looking correct to me. Let's see option D, and then we will finalize the mark. Modify the Lambda invocation permission to allow DynamoDB and S3 to log Lambda actions to CloudWatch logs. Okay, so we don't have to modify the invocation permission to allow DynamoDB and S3. Lambda can directly push the logs to the CloudWatch. So I will choose C here. Next one, a company uses AWS SDK for JavaScript in the browser to build a web application and then post the application on S3. The company wants to support the 10,000 users concurrently. The company selects Amazon DynamoDB to store user preference in a table. There is a requirement to uniquely identify users at any scale. Which solution will meet the requirement? Option A, create a user cookie, attach a role to the S3 bucket that hosts the application. Deploy the CloudFront distribution with an origin access identity to access the S3 bucket. Configure and use the Cognito access DynamoDB with the authenticated user, and create an IAM user for each user and use fine-grained access control on the DynamoDB to control the access. What we are looking for? It is looking for there's a requirement to uniquely identify users at any scale. Okay, that is a requirement. Okay, it's talking about identifying the user. Let's try this one. Configure and use Cognito access DynamoDB with the authenticated users. And that seems correct. Why others are not correct? S3 does not provide the ability to use a role, and A is talking about attach an IAM role. Option B, we can use origin access identity to restrict access to the S3 bucket from public internet by ensuring users access all the content through a CloudFront. However, you can't use the OAI to identify the user. Okay. Option C, I've already discussed. And option D, I'm talking about IAM policies make fine-grained access control possible in DynamoDB. However, IAM is not intended for the application authentication or authorization. Okay. Because there are 10,000 users, the solution would exceed the quota for the users quickly. So C is looking the most appropriate to me. Number 59, a company's developer is creating an AWS Lambda function that will read the data from an RDS database. The company's security policy requires database credentials to be encrypted at rest. The database credentials must also be automatically rotated. The Lambda function needs to be able to read the database credentials securely. When it comes to automatic rotation, search for the option of secret manager. Okay. I can see I have one option that is talking about secret manager. I will see this one. Create a secret manager secret for the database credentials encrypted with KMS key. Modify the Lambda function to retrieve the secret from secret manager. Attach a custom policy to the Lambda function execution rule to allow access to the secret manager, get secret value from the secrets ARN, and to allow access to KMS, decrypt from the KMS key ARN. Okay. You can read the other pointers, and after reading the other pointers, I will go by option A. I can just wait for these pointers. You can read it. D is talking about system manager parameters store, which does not support automatic rotation. I'm eliminating it. C is talking about create a secure string parameters in the system manager parameter store. Again, I'm eliminating it for the same reason. B is talking about create a S3 bucket for the database credentials, encrypt the database credentials with the server-side encryption with KMS. When we directly have an option for the secret manager, why we will go for a complex solution? I will choose A, and that is the correct answer. Okay. A company is developing a microservice that will manage customer account data in an Amazon DynamoDB table. Insert, update, and delete requests will be rare. Read request will be heavy. The company must have the ability to access the customer data quickly by using a customer ID. The microservice can tolerate stale data. Which solution will meet these requirements with the fewest possible read capacity unit? Two things. Application can tolerate stale data. Application requirement is a fewest possible read capacity unit. I will straightforward go with the eventually consistent read. Okay. And that gives me the correct choice. I can pause on other options. Option B, read the table by using strongly consistent read. Option C, read the table by using transactional read. And option D, read the table by using strongly consistent particle queries. Okay. That is the correct answer. So I will keep my discussion till here. In the next and the final video, we are going to talk about the remaining questions as a part of this official practice exam. And then we will see like the scenario or the questions type which would be there as a part of the examination. Okay. So I will keep my discussion till here only. In the next and the final video, we are going to discuss the remaining questions of this official practice exam. Till that time, keep exploring, keep learning. Thank you very much for watching this video. I will see you all in the next video.